Hello, happy Friday. I hope you made it to the end of this week too, all right. And if you are having any questions about any of the homework, please let me know since that's due today. I told you that we would continue today with our linear homogeneous systems. So we're going to take this fundamental matrix from our last problem, which you hopefully have in your notes, and we're going to do it as an initial value problem. And this will be our initial value right here. So y sub 0 is going to be 374. We're going to use the fact that y, our vector value function here, is equal to our fundamental matrix times our C matrix. And we're also going to use the fact that if we evaluate y at 0, that's our initial value here. I think I didn't include that, is t sub 0 is equal to 0. So if we take that and plug that in for y, we get this. And if we do the same for our fundamental matrix and solve for C, then we can use some of our matrix equation properties to figure out what C would equal in order to get this as our solution matrix here. So what we're going to do is go ahead and use this form right here. We are going to evaluate our fundamental matrix at 0. So if I plug 0 in for T everywhere that I have a T here, I will get my fundamental matrix evaluated at 0 will look like this. Okay, and that is getting multiplied by our C matrix. So that will look like C1, C2, C3. And we're saying that that gives us our y of 0, 3, 7, 4. Okay, so using our matrix equation properties that we've learned, what we could do a couple different things. In order to solve this, we could find the inverse here. You have a variety of ways of doing that, and that's the method that we're going to use here, is the inverse of this fundamental matrix. And I'm going to shortcut that for us because I have the fundamental matrix here for you. But basically, one of the quick ways that we found the inverse for this was we used Cramer's rule. And if you remember, that involved finding cofactors for each of these elements, and then we swapped them over that main line there. So you can go back to your notes from March, hopefully, and I think Cramer's rule for finding an inverse matrix would probably be the easiest. And so what I'm going to do is, like I said, I'm going to go ahead and shortcut that. So we're going to come over here, because if I have my inverse, then the way that I could rewrite this using the inverse is that C is equal to the inverse of the fundamental times y of 0 is basically what we have. So I went and found the inverse. I got this. And then we know C is just going to be that C1, C2, C3. So we'll bring that over. Oh. And we know that y of 0 is that 374. So essentially, in order to solve for your initial value problem here to get C1, C2, C3, you're just doing a little matrix multiplication. That's really it. If you know how to find the inverse, then that really is the piece that takes the longest. So these are not super tricky. When you go through and do that matrix multiplication, and you can pause right now if you would like to do that and just brush up on that. So pause the video. And then once you solve for that, what we get out of that matrix multiplication is 2, 1, 4. Okay, so we're not done just because we wrote 2, 1, 4. See, I wish I could. Oh, I can move this like I can move stuff on my smartboard. Good. Okay. Let me actually scooch this over if I can a little bit here. Just, I don't know why it made it gray. Okay. So move that over. This is the result of my matrix multiplication right here. But this gives us our final solution. We have to go back and write this out as what we got in terms of our matrix. So that is the part that I actually didn't write down. But that is okay because remember that if we took this, oops, sorry about that. If we took this, it was multiplied by C. So it was C1, C2, C3. We now have C1, C2, and C3. So remember, C1 was equal to 2. C2 is equal to 1, C3 was equal to 4. So essentially now we're just going to do the matrix multiplication with these two matrices to get our final answer for Y. So Y, we can write in this matrix format like this. And let's see if we can zoom out so I don't have to keep scrolling up and down on this. There we go. All right, if I do my matrix multiplication, what I'm getting for my element in my first row here is 2e to the 2t plus e to the 3t plus 0, because I take e to the 2t times 2 plus e to the 3t times 1 plus 0 times 4. All right, for my second element, I'm going to go ahead and get 4e to the 2t plus 3e to the 3t plus 4e to the t. No like terms there, so we don't have to do anything more with that. And then for my last, oh, and you know what? I am wrong about that because the last one here, I was looking at this. It's 0 times 4 for that last piece. So actually, we should just be getting 4e to the 2t plus 3e to the 3t. My mistake. Okay, for our last row here, 0 times 2 plus 0 times 1 plus, that's where I get my 4e to the t, if I looked at that correctly. Okay, so this would be then, if we're solving an initial value problem, this would be an acceptable final answer for Y, because we can now write this out. And essentially what we've done here, let's just keep in mind, we're solving differential equations. We're solving now multiple differential equations all at once. So basically what we found here is Y sub 1, a solution for Y sub 1, one of the solutions that will work for our system of differential equations. We found a Y sub 2 and we found a Y sub 3. And so and these are, because it's an initial value problem, these are particular solutions for those differential equations that we're solving. So I'm going to have you pause here again for a second because I want you to try this. Part A, show that the matrix is a fundamental matrix for the given differential equation system. So this is my proposed fundamental matrix, and it has to work for this right here. So what I want you to do is, we talked yesterday about substitution. We also talked about finding the determinant. Okay, I want you to do both here for part A. Pause the video and come back when you're ready. Okay, so I hope you took a second and did this in a couple of ways to show that we have the fundamental matrix. So let me just show you what I did. For the proposed fundamental matrix here, I went ahead and found the first derivative. So you can just derive each of the elements individually here. And what we're looking for here is, if that is what the first derivative looks like, we're saying, according to this equation, that that should be equal to this A matrix times Y, our original fundamental matrix right here. So what I did was I took this A matrix and I multiplied that by my original fundamental. And I kind of showed some of my steps right here, but basically, 1 minus 1 here, we get 0. E to the t plus 0, I get e to the t. Here we get some cancellation, so I get 2e to the 2t. Here we get 0, 0, and then we get some zeros here, so we're just left with 4e to the 2t. And then 0, again, 0, and then these are just nothing, so a negative 2e to the 2t. So now I can go back and take a look and, oh, yep, that matches with what I got for the first derivative. So that's one way of verifying that looks good. All right, the other way is to find the determinant of our 3 by 3 fundamental matrix here. So I did that, and we got 1 times 0 here, which would just be 0. We get negative e to the t times 2e to the 2t. So it looks like we're getting negative 2e to the 3t. And then here, e to the t times 0 would just be 0. So I got negative 2e to the 3t for the determinant, which is not equal to 0, which means this also checks out that we have a fundamental solution. Okay, so once we know that, now we're just going to practice finding the general solution, or I guess forming the general solution, and then solving if we are given the initial value problem, which I didn't include here. But I'm going to have you form the general solution. Go ahead and pause the video, and let me give you your initial value problem. So I don't know what just happened. Got a little carried away. I'm sorry. All right. So y of 0 is going to be 0 to negative 2. So go ahead and pause again, form the general solution, and then use that initial value problem to determine what your particular solution will be. Okay, I hope you did a little solving. I didn't show as many steps here, just I figured it might be a little quicker to do it this way. But I did write out y of t here. Now you can do one of two forms. You could either do this as my fundamental matrix times c, totally fine to leave it in that matrix form, or think about writing it in this this format here as well, where you actually do the matrix multiplication, especially if you have some zeros in here. It does make it look kind of nice to just have it that way and to show all of your different solutions, especially if you are solving an initial value problem. Now, this is where I really didn't show some steps. This is what I got for C. Hopefully you got the same. You can let me know if you have any questions about that. But that means that we can plug that directly into this second format that we used right here to write out the particular solution. And so that's what I got for the particular solution right there. So check your work again. Always let me know if you have any questions. And I hope you have a wonderful weekend.